as a little bit of a bonus here at the end of this particular lecture, I'm going to go ahead and deal with solving one of the problems that's going to show up on your homework for this lecture. And part of the reason for that is it gets to showcase some of the identities we haven't used and some of the other tactics we haven't used. And also, I feel like when you're asked to fill this in WebAssign, it kind of skips over some of the important key ideas and steps. So we're going to take a look at this together instead. So we're going to be asked to verify the following identity. We have cosine of x plus sine of x times tangent of x equals secant of x. So again, remember that was something like this. There are lots of different ways in which we can choose to tackle it. We're going to go ahead and work off of the first guideline that was suggested in this section, that we should work with the more complicated side first. That's definitely going to be the left-hand side here. Now, looking at what I've got a pretty eclectic mix here, because I've got cosine and sine, and I've also got a tangent here, so 3 different trig functions. Well, okay, with that in mind, here's maybe a thought. How about I go ahead and try and start with converting this to only deal with cosines and sines? That at least gets rid of one of my trig functions, and I know that tangent can be written as a quotient of those things. So let's start by using our quotient identity. We're going to swap out tangent for sine over cosine. So right now we've got cosine of x plus sine of x times now sine of x over cosine of x. Now with this here, we can go ahead and multiply this with the numerator here, as we should, to give us an even more condensed term. So just a little bit of algebra, or again arithmetic if you prefer. I'm using them interchangeably in this case since the work that we're doing really doesn't use the variable in any relevant fashion. We're just essentially combining terms according to normal operations here. Now we have cosine of x plus sine squared x over cosine x. Now this might seem kind of strange, like, all right, where are we going with this? Well, here's what we want to do. In this case, I would like to go ahead and combine these one step further. The same way that I combine these into a single expression, I can also combine these. And this is one of the guidelines they mentioned. One of the things that they said is, why not try to add fractions? And in this case, we have one fraction and another term. If we were to add these together, I would need to go ahead and create a common denominator. Since this has a denominator of cosine of x, I want to give this a denominator of cosine of x. So I'm going to multiply it on the top and bottom, because I can think about this as cosine of x over 1 by cosine of x. So again, a little bit of algebraic thinking here. This is going to turn into cosine squared x over cosine of x plus sine squared x over cosine of x. Now that they have a common denominator, I can pull them together into a single fraction. So this is cosine squared x plus sine squared x all over cosine of x. Well, you should recognize that expression up top. Cosine squared x plus sine squared x, that is our Pythagorean identity, our original one. We know that that can be replaced with 1. So this is now 1 over cosine of x. That means our final step here is to use our reciprocal identity. 1 over cosine of x, that's the exact definition for secant of x. And there we have it. We've verified that this expression on the left-hand side is equal to this. There's a couple pieces that I want to go ahead and include here just as kind of like a side note. And this is kind of along the lines of what I was talking about earlier. Let's say that in a later section we're asked to solve the following equation. I want to know, when is cosine of x plus sine of x times the tangent of x equal to, let's do 2 in this case. Okay, this would be awful if I gave it to you in a later section, if I just asked you to go ahead and solve this. But according to the work that we're seeing here, we know that this expression on the left-hand side is equivalent to secant of x. So I can replace this with secant of x and be perfectly okay. This is just applying the law of substitution here. I can replace any expression with something that it's equivalent to. And secant of x equals 2, well, that's nothing. This is just basically asking when is cosine equal to 1/2, and there's a couple locations where that happens. In this particular case, if I were to solve this, I would say, okay, well, that's going to be whenever cosine equals 1/2, which is going to happen at pi over 3, and every 2 pi n after that. It's also going to happen in quadrant 4, which would be at 5 pi over 3, plus every 2 pi n after that. We'll talk a little bit more about this in a later section when we focus on solving trigonometric equations, but this is meant to show you an example of how we can use these trigonometric identities that we're verifying here to make other work easier. The last thing that I want to note here is this that I've been doing at the end of some of these. This is just a quirk that I picked up when I first started doing trigonometric identities in high school. These 3 dots here stand for something that you might have seen in logic, QED. And I believe, I can't remember the exact Latin for it. It's like quod erat demonstratum, basically that which was to be shown. Basically saying, hey, I showed exactly what I set out to show. Hey, I verified the identity that you asked me to do. Some students have asked me about that, so I wanted to go ahead and include that here. All right, that's going to do it for this section. I'll see you guys in the next one.